Every portable device today, from smartphones to IoT sensors, faces the same challenge: limited battery life. The more features we add, the faster batteries drain. That's why engineers use low-power design techniques to stretch every milliamp hour. Most microcontrollers and processors operate in multiple power modes. Active mode, when the CPU and peripherals are fully running, consuming the most energy. Sleep mode, the CPU is paused, but essential peripherals remain active to save power. Deep sleep mode, only the bare minimum circuits stay on, giving the lowest energy use. Switching between these modes smartly is the key to battery efficiency. Beyond power modes, there are circuit-level techniques to cut waste. Clock gating turns off the clock signal to unused modules, reducing switching activity. Peripheral shutdown powers down unused hardware like ADCs or communication blocks. Duty cycling runs tasks only when needed, then switches back to sleep, common in wireless devices that wake briefly to send data, then sleep again. But how do devices know when to wake up? Timers can wake a device periodically for scheduled tasks. Interrupts from sensors or communication interfaces can trigger wake-up only when an event occurs. External events, like a button press, can also bring the system back to active mode. This event-driven wake-up ensures the device stays asleep as long as possible. Here's a quick checklist for designing battery-friendly systems. Measure current consumption in each mode. Reduce by turning off everything that's not needed. Test in real-world scenarios to validate battery savings. By carefully managing power modes, peripherals, and wake sources, we can make devices last days, weeks, or even years on a single battery.